Hello student, in today's lecture we see second chapter of first paper. Chapter is Regression. Regression analysis is a mathematical measure of the average relationship between two or more variables in terms of the original units of data. Next point, linear regression. If we plot the bivariate data using scatter diagram, then we observe that if the variables are related, then the points cluster around some curve. If this curve is straight line, then it is called a line of regression, and there is said to be linear regression between the variables. The line of regression is the line which gives the best estimate to the value of one variable for any specified value of the other variable, and this line is known as the line of best fit. When we measure deviation along y-axis for given value of x-axis and obtain the line of best fit using principle of least square, we get the line of regression of capital Y on capital X. Similarly, when we measure the deviations along x-axis and obtain the line of best fit using least squares principle, we get the line of regression of x on y. So this figure and this figure indicates line of regression on x, and this is line of regression of x on y. That is, this is y is equal to a plus bx, and this is capital X is equal to a dash plus b dash y. Next point is fitting of straight line using least square method. First point is deviation of line of regression of y on x. Let open bracket small x1 comma y1 comma x2 comma y2 comma so on up to xn comma yn be n pairs of observations on the two variables capital X and capital Y. Let capital Y be dependent variables and capital X be an independent variable, and let capital Y is equal to a plus bx, this is equation number 1, be the line of regression of capital Y on capital X, where a and b are constants for any point pi of xi comma yi. The error or deviation along y-axis for given value capital X is equal to small xi is given by, that is, di is equal to yi minus yi cap, which is equal to this yi minus yi is a plus b xi, that is capital X is nothing but xi, where yi cap is regression estimate of capital Y for given value of capital X is equal to small xi. We have to find a and b in equation 1 by using the principle of least squares, such that the sum of squares of deviation is the least, that is, we have to minimize. So capital S is equal to summation di square I running from 1 to n, which is equal to summation di is nothing but yi minus yi cap. So summation yi minus yi cap bracket square, which is equal to summation, and yi minus yi cap is equal to yi minus a minus b xi, that is value of yi cap is a minus a plus b xi bracket square. We know that S, which is a function of a and b for a given bivariate data, will have an extreme, that is either maximum or minimum, if its partial derivatives with respect to a and b are equal to 0 respectively, that is, if daba s upon daba a is equal to 0 and daba s upon daba b is equal to 0, that is partial derivative of this capital S with respect to a and with respect to b is equal to 0. Then now first dabba s upon dabba a is equal to 0, which implies for then differentiate this s with respect to a, we get that is dabba by dabba a summation yi minus a minus b xi bracket square is equal to 0. That is summation derivative of summation yi minus a minus b xi bracket square is equal to summation 2 into yi minus a minus b xi, and derivative of this a is minus 1 is equal to 0. In next step, dividing by minus 2 and simplifying, we get that is divide this equation by minus 2 and simplify, we get summation yi is equal to summation a plus b summation xi. That is divide this term by minus 2, we get summation yi minus a minus b xi is equal to 0. Then apply this summation on bracket, we get summation yi minus summation a minus b summation xi is equal to 0. Then this term is as it is, summation yi is equal to, take this term in this side, so we get summation a plus b into summation xi is equal. Therefore summation yi is equal to, we know that a is constant, so take a is outside the summation, so a into summation 1, and we know that summation 1 is nothing but n, so which is equal to n into a plus b into summation xi. This is equation number 3. And dabba s upon dabba b is equal to 0, which implies that is differentiate take partial derivative of s with respect to b, we get that is summation 2 into yi minus b minus yi minus a minus b xi. In next bracket, derivative of this b xi is minus xi is equal to 0. Also divide this term by minus 2, we get that is summation xi minus in bracket yi minus a minus b xi is equal to 0. Apply this summation in bracket and multiply this xi in bracket, we get that is summation xi yi is equal to a into summation xi plus b into summation xi square. This is equation number 4. The equations 3 and 4 are known as normal equations for estimating a and b from 3, and dividing both sides by n, we get, so divide this equation by n, we get summation divide equation 3 by n. Equation 3 is summation yi is equal to n a plus b summation xi. So divide this term by n, we get summation yi upon n is equal to n into a upon n plus b into summation xi upon n. That is, this is summation yi upon n is nothing but the mean of y bar, that is y bar is equal to n and n get cancelled, so we get a plus b summation xi upon n is x bar. This is equation number 5, and rearranging the term, we get a is equal to y bar minus b x bar. This is equation number 6. Substituting 6 in equation 4, that is, we get summation xi yi is equal to in bracket y bar minus b x bar, that is value of 8 is y bar minus b x bar into summation this xi plus b into summation xi square. Divide both sides by n, we get summation xi yi upon n minus y bar minus is equal to y bar minus b x bar into summation xi upon n plus b summation xi square upon n. That is, summation xi yi upon n is equal to y bar minus b x bar, and summation xi upon n is nothing but x bar plus b summation xi square upon n. That is summation xi upon n xi yi upon n is equal to, multiply this x bar in bracket, we get x bar y bar minus b x bar square plus b y summation xi bar square upon n. That is, take this term in this side, we get summation xi yi upon n minus x bar y bar is equal to, take b common, b in bracket summation xi square upon n minus this x bar square. That is, we know that summation xi yi upon n summation xi yi minus n into x bar y bar divided by n is nothing but covariance of capital X comma capital Y is equal to, this is B, and we know that variance of x is equal to summation xi square upon n minus x bar square. So B is equal to covariance of capital X comma capital Y upon variance of capital X. This is equation number 7, and we know that covariance of capital X comma capital Y is equal to R into sigma x into sigma y, and variance of x is nothing but sigma x square, so which is equal to R into sigma x, and sigma x get cancelled and remaining term is sigma y upon sigma x. This is equation number 8. Therefore A is equal to y bar minus bx bar, which is equal to y bar minus put the value of b, that is r into sigma y upon sigma x, that is y bar minus r into sigma y upon sigma x into x bar. Substitute 6 and 8 in equation 1. We get equation 1 is nothing but y is equal to a plus bx, and which is equal to value of a is y bar minus r into sigma y upon sigma x into x square, plus value of b is r into sigma y upon sigma x, and this x is as it is. So therefore take this y bar in this side, we get y minus y bar is equal to, take r sigma y upon sigma x common, so we get r into sigma y upon sigma x into in bracket x minus x bar. This is equation number 9. Is the equation of regression line of y on x, that is, and the constant b involved in equation 1, that is b is equal to covariance of capital X comma capital Y upon variance of capital A is equal to r into sigma y upon sigma x, is called the coefficient of regression of y on x and denoted by capital X. It is the slope of line of regression of y on x.